Okay, we're live. All right, everyone, welcome to the Open Protocol Discussion, a bi-weekly meeting in which we review and plan for upcoming changes and improvements to the protocol. We've missed a few meetings because people have been out of town, but our plan is to keep live streaming these so that the world at large, anyone who's watching, can see what we're working on and all the wonderful thoughts that we have about how to make Stellar better. These meetings usually focus on reviewing core advancement proposals, aka CAPs, which suggests new features and improvements to the protocol. And at the moment, we're focused on Protocol 14, the upcoming protocol, which will likely include two big CAPs, CAP 23, two-part payments, and CAP 33, sponsored reserves. Today, we'll cover a few remaining questions about those. We'll also talk a bit about the downstream implications of those CAPs and the preparations underway to make sure Horizon and the Stellar SDKs are ready for Protocol 14. So we published some pre-reads for this meeting. They're in the event description. And this discussion will make a lot more sense if you've done them. So do those if you haven't. There's also just a rough outline of the agenda on the left of the screen. And there's also a list of participants in the event description. And for this meeting, instead of introducing everyone, I'll just let anyone watching Google the names to find out who's who. If that's not working in the future, we can take some time to introduce ourselves, but let's start there, seems simplest. So diving in, quick status update. CAP 23 and CAP 33 are in final comment period. They've been there a little longer than usual. There were a few lingering questions. Discussion was a bit slow because people were away. But barring any blockers raised in today's discussion, we will ignite them with the coveted status of accepted. So first, let's talk about those. CAP 23, two-part payments. CAP 23 creates a new letter entry called a claimable balance, and new operations that allow you to create and claim a claimable balance. The goal is to separate the sending and receiving of a payment so you can send a payment to an account that isn't already prepared to receive it. It looks like there are a couple of issues here, and I will turn it over to John to talk about the first one.
Sure. So this originates from a question that David brought up, I guess, a few weeks ago, which has kind of been lingering, but basically, the question is like right now we're using this like predicates tree structure, which is kind of novel in the Stellar world. In other places we use like linear threshold combinations and stuff like that. But here we have this predicate tree. And David's main concern about this predicate tree is that XDR doesn't have any built-in mechanisms to prevent arbitrary recursion. And so anybody who has an XDR parser, first of all, like as a matter of principle, you should be making sure that you're not going to get infinite recursion. But you could imagine a world in which you have some structure which is like sitting on the edge of the recursion depth limit for different nodes on different architectures and whatever. And maybe some nodes choose that it's acceptable and some nodes choose it's unacceptable. And then you end up in some bad undefined state, depending on potentially a fork in a really bad case, depending on basically just how everybody's configured with their different XDR. And so the question is like, how should we update this predicate tree structure? And David had this proposal to basically turn it into into disjunctive normal form. But I've heard some opposition from myself, from Nicola, and from somebody else, although I can't remember right now who the third person is, that this disjunctive normal form idea is not really that great because like complicated expressions end up becoming like exponentially large. That's kind of not ideal. So we could either decide that we don't think this is a problem and we're not going to be anywhere close to the recursion depth limit because like probably realistically a transaction, even with this predicate tree structure, has recursion depth maybe like 10 or 12. And if your system doesn't support like 12 recursions, like that's a problem.
No, but hold on. The idea is that a bad person could purposely submit a transaction that like pushes the recursion depth.
Right, but that would be invalid no matter what. They're automatically invalid if the depth is greater than 4. So like if you submit
because we have logic in there we have to.
Yeah, exactly. The transaction is just unilaterally invalid if any of the predicate trees have depth greater than 4. So like it might, if your XDR compiler doesn't generate code that handles recursion, like deep recursions well, it might crash your node. But like if that's the case, your XDR setup is garbage and you have a security vulnerability regardless of whether we've done this or not.
Well, if we pick a number like 4, we can actually, I mean, it's ugly, but we can actually express that in the XDR.
It'd be
by
really
having,
gross, though.
predicate tree 1, 2, 3, and 4 is like 4 different types, or, leaf 1, 2, and 3 or something. I mean, but so the other question is how, like, do we really actually have use cases that involve all of this? Like, the thing is, you already have the disjunction because you can have multiple claimants, right? And so the question is, why not do something that has just a conjunction, in the claim predicate, and then we can add something more if it turns out that's not useful enough, or at least come up with some actual like realistic use case that actually requires like like for deep nesting of like ands and ors.
So the 4 wasn't chosen arbitrarily. The 4 has this like very magic property of making a claimable balance entry the same size as or rather the claimable predicate tree the same size as a data field. So basically, like, this 4 was basically saying, like, if you're going to pay a reserve to get a data field, you might as well pay a reserve to get the same amount of space in a claimable balance. But so that's where the magic 4 comes from. But regardless of that, I mean, like, for me, it's not just about whether, like, everything I think sensible that you could express today, you could express in disjunction format. Like, I don't see any reason why you couldn't do this. But the issue is, like, if we then subsequently add the conjunctive stuff, then we're no better off than we are now. Like, we'd be strictly worse, in fact, because we'd now have this implicit disjunction thing, which was your proposal, where basically if you get disjunction if you have the same claimant multiple times. That's currently not permitted at all. Claimants are unique in the current proposal. But then you'd also be able to build these trees. And then you've like kind of violated the like one way to do it rule. So like that's kind of my main, like, basically if we think we could ever end up in a world where DNF is not good, then we shouldn't start in a world where DNF is the standard, because we'd be no better off in the long run. So that's kind of my main take on it. One other idea I'll pitch to you, and I'm going to credit this one to Graydon. It's not my idea, but Graydon mentioned that we could actually, to avoid the infinite recursion thing, XDR opaquify the predicate tree. And like we could, for example, make the XDR opaque version of the predicate tree like 64 bytes right now. And if it's bigger than 64 bytes, you're dead. Like, that's not going to work. And then later, if we need to get bigger trees, for example, for hash preimages or something, we just increase that number. But that provides like a default bound automatically. I don't know. I don't know how much anybody cares about this at the end of the day. Like, we could definitely do the hard coding thing. There's a lot of different options, and I don't know how much it matters to spend time trying to decide. Like, do people care a lot? Are people really concerned about this recursion thing?
What is the use case that's driving the more complex like predicate trees?
Well, the main reason for having the predicate trees is just that it's a lot more powerful than having linear like signer weights, basically, like what we have on accounts. There are very simple situations where you would want an or, for example, or maybe even an and or an or. For example, like you might want a situation where it's like, from now until this time, I can do something, and then from some future time until some other future time, I again have the right to do something. And now you've automatically got this tree structure implicitly. So,
but you can already have this because you already have multiple claimants, right? So,
but the claimants are unique right now. They don't support repetition, but we could do repetition.
Sorry, but you're saying even the subunits of the claimants, if you have a conjunction of me before Tuesday and me after Thursday, you're saying those are the same claimants, or the same claimant has appeared multiple times.
Correct, and that would be invalid.
So yeah, so I don't see why would you prohibit that? Like, I can actually see a number of reasons why you might want to do that, because like maybe you want to be able to be claimed by like a 2 out of 3 configuration, and so like I should be able to sign on 2 of the claimants, for example. So having repeated claimants actually seems like a very useful thing, unlike this alternating and or 4 times.
I'm not sure I understand why the repeating would be useful, like other than in this disjunctive normal format world. Like why?
Okay.
what usage could possibly come from that? It's strictly less powerful than the tree. Like anything you can do with the tree, you could also do with the claimants, like repeated claimants. But the opposite
Let
statement
me
is
think about
false.
it.
Anyway, I want to come back to like, I don't want to spend time about this if nobody's concerned about this recursion issue. Like my stance on the recursion issue is that if the recursion issue comes into play, you already have a security vulnerability because your XDR compiler doesn't handle recursion well, or your XDR library doesn't handle recursion well. So not.
But the question is, like, do we define a depth specifically for this data structure, or we just expect to conform to whatever your XDR parser knows how to do?
This one has a specific depth limit.
But there are two parts to it. Yeah, there are two parts to it, right? You have, from a security standpoint, you want to be able, like, you should never use, unbounded, amount of memory if you get untrusted data on the wire, right? And then there's the second part that is a protocol enforced thing, that is, what is the maximum depth? And it's 4.
So in that case, if that's really what we're going to do, I would argue against the maximum depth because that's hard to implement, right? So people get it wrong. If we just have a maximum, do we have a maximum transaction size? Because the thing is, like, a maximum transaction size would at least be easy to enforce.
David, I think I'd rather not go that route because, like, right now, like John said, like the 4 has this kind of nice property where we don't have to deal with variable-based reserve requirement on this. Like, as soon as we say we bound this to the size of the transaction, now you have to come up with a new model for this, for how much to charge for, because now, like, there are going to be potentially a lot more predicates that you can put, because operations can get very big.
So how big is your
like
implementation?
a path payment is is very big. So
how big is your implementation of the recursion depth, John? How many lines of C++?
Siddharth did it, so I don't have it in my head right now, but my guess is it's probably like on the order of 20. That's how much I think it would take me to implement it.
And how many places do you have to invoke that function in the code? Because it seems like we're gonna have to check this in a bunch of different places, right? Every place.
Just one.
Yeah, it's
just on create, because they're immutable. So it's just like in the validity path, you check like, hey, like how deep is this? Cool, you're good.
I mean, and how? So we need like basically we need a version in the SDK, and then we need to like check that the two are equivalent, right? It seems like anytime there's a difference, like anytime an SDK can be convinced to create a transaction that Stellar Core will consider incorrect or invalid, that's exploitable, right? Because I'll convince you that, hey, we're going to do this thing where you can like claim a bunch of money or whatever, and then it turns out that you can't because Stellar Core rejects the transaction. So I don't like this idea that, like, I don't think we should never do it. Like, there are clearly times when it's appropriate, but it doesn't seem justified here to add like an extra validity rule that is not like
David, like
XDR types.
This is not a good argument, I think, because like in general, like you have an expression and you're saying, oh, like I want to look at the expression and I expect it to just pass in core, but like really, like if this expression is bogus, like it doesn't matter. Like it's going to be invalid later.
Right.
Like
so I'm saying
we should many other reasons.
We should make it as easy as possible for SDKs and other software in the Stellar ecosystem to replicate the validity rules of Stellar transactions. And obviously, sometimes we need to add extra logic. But given that we haven't cited a single use case that it wouldn't be satisfied by a simpler approach here, it doesn't seem justified. But again, I mean, I've said my piece. I don't object strongly enough that I'm overruling this. I did vote to put this to FCP, so you guys can heed my advice or ignore it, I guess.
How would you feel about the hard-coded thing, the leaf 1, 2, 3 thing?
Better, much better.
Because that would be easy to do, and it wouldn't really impact the implementation at all, because all I would do in the implementation is just parse it once, the leaf 4-way or depth 4-way, and then I would just parse it again as an infinitely recursive structure once I've checked that it's fine. And
Sure.
and then you can just XDR SDKs and whatever could just parse it as the 4 depth version, and it would just work out of the box.
Actually, we would not even use the one with the labels in core.
Yeah, in fact, we might not even use the one with the labels in core. Exactly, that's a good point, because we know that we're secure against arbitrary recursion. So
no. But the whole point is we want the logic in core to exactly match the logic in SDKs, right? So
it is to fully specify. I mean, we are saying the specification is 4, maximum depth 4, right? So it would be the same spec.
And we'd just be giving a canned version to SDK developers.
I'm very skeptical that the 4 is even necessary. Why don't we start with 2, and then if we need 4, we can do it.
Yeah, we could start with 2. 2 is fine, but I mean, 2 hasn't helped you a ton, in the sense that 2 has exactly the same constraints as 4, right? You'd still need to check the depth and everything.
Well, no, because 2 is much less unwieldy to do with a leaf and an internal, right? Now it's it's not that bad to have 2 different types for it.
Also, you would need, well, I guess do you mean 2 as in root 1, 2? Because
no,
you want an and of 2 ors.
I meant I just meant when you have an and or an or, it's an and or an or of something that doesn't include and an or of a leaf.
That's a lot more restrictive.
But again, what are the use cases here? This feels to me like we're building a mechanism without an idea of the use case for the mechanism, right? And you can always increase the depth, right? That's not a problem.
That's a fair point. You can always increase the depth.
On the other hand, it may turn out that the main bottleneck here is that it's it may be very unintuitive to have and an or complicated Boolean formulas for this stuff, right? I think a simple one level, a disjunction of conjunctions is something that intuitively makes sense. Okay, there's 3 conditions on which we can do this. It's this and this are true, or this and this are true. But once you start going to more than 2 depths, it starts becoming fairly unintuitive. It's what you expect to feed into your stat solver because you've generated it from whatever, but it's no longer going to correspond to sort of simple human expectations. So do we actually expect that we're going to be having compilers generate these really complicated predicates, and that we're just going to trust these compilers to do something sensible? Or do we just if we have a use case for that, I'm okay with it. But until we do, I'd say why not just defer having that complexity?
I mean, I'm not opposed to going to 2 in the short term and making it super simple, and we can make it higher in the future when we need it.
Would that be difficult if we started shallow and decided that it needed to be deeper? Would it be difficult to make that change?
No, it'd be very easy.
I think that I have an idea how to implement this without the recursion. Maybe we can just allow the predicate to be an array of predicates and allow duplicate claimants in the conditions. So with these 2 preconditions, we can implement both and or cases, because duplicate claimants, for example, 2 or more claimants with the same account ID with the same destination, will allow to implement OR cases, and making the predicate an array of predicate predicates, it makes the overall thing easier.
Well,
I
that's
see
a
David
great
smiling
idea.
because that was his proposal.
Okay.
Okay, let's.
I
Okay,
think
Sorry,
I think it's
sorry.
intuitive. It's intuitive. It's like it makes sense. It is fairly expressive.
clearly there's a lot of different opinions here. So let's take this.
Yeah.
I think we've talked out some of the details here.
Okay.
Let's take it to the mailing list and try to come up with what's the right thing to do. Like
Sure.
the beautiful thing is like none of these changes are going to be very material to the implementation. So we can plug in whichever one we kind of think is the right one. But I don't want to take the entire time of this meeting talking about this one thing.
Okay, so the plan then is to make these suggestions on the mailing list, evaluate them asynchronously, and choose one for the implementation soon. Okay, that's what we'll do then. That
I'll
sounds
send
like
out an email
everybody?
after this meeting kicking that off.
Cool. Then is there anything else that we need to cover on Cap 23, or is that sort of our procedure forward with that?
I think we could probably take, if people want to talk about the other thing about like changing this before and after notion to having a not, we can do that, but we can probably take that to the mailing list too, because they're all kind of bundled up as one kind of topic. So unless anybody really wants to talk about that right now, I'd say let's take it to the mailing list.
Great, we'll take it to the mailing list. Look out for that in your inbox, everyone.
Get excited.
So then we'll move on to Cap 33, sponsored reserves. This proposal allows an entity to cover the reserve for accounts controlled by other parties without giving those parties control of the reserve. It extends account entries and ledger entries so they record pertinent information about sponsorships. It creates new operations to initiate and terminate sponsorship and to update sponsorship information for existing ledger entries. The goal is to allow asset issuers and wallets to cover user reserves, basically. One issue came up, which is that there was some incompatibility with SEP 30, which is a Stellar ecosystem proposal that defines an API to allow users to regain access to a Stellar account after they've lost their private key without providing any third-party control of that account. And so I think there's been some investigation of how to deal with potential incompatibilities, and I'll turn it over to Lee.
Yeah, I can give just a quick description of what the incompatibility is. And then we've got a short-term fix at the SEP level, and then John will talk about a potential way we might want to think about this at the protocol level later on as well. So the incompatibility is that SEP 30, because the server that implements SEP 30, because it's signing transactions for multiple accounts, it has this rule defined in the SEP that says that the server should only sign a transaction if the operations and the source account on their transaction and the operations is for the account that's registered, the account that it's signing for. And the latest version of Cap 33 has things like adding signers, including other operations that have to be signed by the sponsor account. So because this transaction that adds a signer that's sponsored has multiple accounts signing it, a SEP 30 server would reject this transaction. So the short-term fix that we're thinking of for at the SEP level is just to alter that rule so that a SEP 30 server implementation can choose to allow the source account of operations to include some limited set of accounts that it knows that it won't be signing transactions for. And that should allow us to add, say, the sponsor to that list of that limited set, and would allow those transactions to be signed. And John also has an idea of how to deal with this in another way at the protocol level. Do you want to share that, John?
Yeah. I wasn't sure you were done talking. Didn't want to interrupt you. So this harks back to a super duper old issue from actually opened by Jeremy Rubin, like, I don't know, more than 2 years ago. It's protocol issue number 93, if anybody's interested. But basically, Jeremy's observation was that signing transactions in the world of Stellar is very susceptible to the confused deputy problem. And the basic idea behind the confused deputy problem, for people listening, is basically like, or at least how it applies in the world of Stellar, is suppose you have two accounts, both of which that can be signed with a single signer, a single private key. And then you look at some transaction and somebody asks you to sign it for one of these two accounts. But what you don't realize is that it actually contains operations for the other account as well, and you've now signed it for both accounts, and it's good to go. And now you might have authorized something that you did not mean to authorize. There are other manifestations of this as well. For example, like it could be a more complicated world where like you have multiple keys and somebody asks you to sign for a certain set of keys, and those keys combine to sign for some third account that you didn't realize you were signing for. So at the time, Jeremy opened this issue and asked a question, which was something like, John will know the best way to implement this that wasn't annoying. But at the time, there was no way to implement that wasn't annoying, because there was no way to change signatures. But since David's cap 19, which got like subsumed into cap 15 and introduced the new transaction envelopes, we actually have the power to change signatures in a very clean way. And so the gist of my proposal is basically to add a new kind of transaction envelope, which we'll call, like, for the sake of this discussion, transaction envelope no confused deputy, but that's a terrible name and we wouldn't actually call it that. I don't know, I'm no good at names anyway. Somebody else would probably think of it. And basically this transaction envelope, it would take the normal transaction, but it would require a different type of signature and a different type of signature payload for that matter. So signatures for an existing transaction, like a transaction V1, don't work here. But these signatures would basically have a new bit field wrapped into the signature payload saying which operations you're signing for and also whether you're signing for the source account. And then when you provide the decorated signature, you provide that bit field again. And since the signature is over that bit field, you know that you've gotten the right data when you verify the signature. Like if you try to verify the signature, it contains that bit field, and so you know whether you have it or not. And then you just apply the signature weight to the operations and potentially the source account that match that bit field. So this would be like a pretty clean approach, and it would allow you to sign for like every single thing in a transaction envelope. It's pretty neat. It'd be some work to do, and it would require overhauling a lot of the Stellar Core signature processing stuff, but I don't think it would be like breakingly challenging, excuse me.
But to be clear, the idea would be to try to proceed with cap 33 now and work on these changes later.
Yeah, exactly. I mean, like from my perspective, as long as there's a way to solve the problem and we're recognizing that like the problem is beyond the scope of cap 33, it's kind of like we could always choose to do this if people are encountering this problem all the time. Whereas like if we had no proposed solution at all, then that's a lot scarier.
Right. I mean, I suppose we could also see how many people use SEP 30 and how this SEP level change affects people and whether it solves the problem, which it might, right?
Yeah, I think that the reason that this incompatibility is important is that people who use cap 33 are the people who may use SEP 30 and vice versa. And it's compelling to want to use both. But yeah, I think there's no reason to change cap 33 because of this problem. I think what John is saying is right. This is an underlying issue that we should address on its own. And we do have a way to move forward with SEP 30 and cap 33 together anyway.
Great. All right, it looks like there's one other issue here about changing sponsorship checks. Is that true?
Sorry, I was trying to remember what
from apply to validity.
Yeah, so right now, the way that the cap 33 is written, the way that I've been implementing it, like we would accept transactions that have, like, for example, like bad sandwiching, but these transactions are 100% guaranteed to fail at the time of apply. You don't need, like, normally when we do validity checks, we're doing them on a single operation level. But like the reason for that is normally just because operations have side effects and we can't necessarily tell what they are. But for all of these sponsorship operations, like for beginning and ending and the sandwiching, like you don't need to do anything to know. Like I can look at a transaction and tell you if it's properly sandwiched without applying any of the intermediate operations. And so the question is whether we should allow these transactions to make it to apply time and then fail at that point for being improperly sandwiched, or whether we should just say like, no, your transaction's stupid and it's invalid. Doing that would probably require some new machinery, but like it's not conceptually hard at all. It's just new stuff to build. Whereas doing it at apply time is very easy, which is why I took that approach. But it has the disadvantage of allowing people to spend money on stuff that, and also spend time on the network with stuff that's like obviously not going to work. So I don't know if people have a strong feeling about this. I know I've discussed it with Nicola before, but I don't know whether I don't really know which way he wants to go with it.
I mean, for what it's worth, I would have thought we would check this kind of thing in the SDKs as well, and even possibly in Horizon. I haven't actually thought about it, but as you say, it seems trivial to check.
I mean, like, yeah, like for me, it seems like it would be a good candidate to have this as the validation step. Because it's, we're trying to, it's a usability thing, I think. That said, if we think that sandwiching is more of a like remote in kind of a niche thing, maybe it's not worth it. I mean, either way, it's fine to me. It's more like, yeah, a trade-off of work versus, because we can always change that later too. So it's not like a.
That's exactly what I was going to say, that we always have the power to change this later.
I also don't think it makes a huge difference to usability, because somebody running these types of transactions is probably going to be running a lot of these transactions. So they're going to find out really early in development. Like they're not going to, hopefully, I think it's unlikely that they're going to run like 10,000 of these transactions and then see them all fail. They're probably going to run one during testing, see it fail, fix the code, and then move on.
That makes
I think
a lot
that's
of
a
sense.
strong point. This is like a kind of like an enterprise tool, not really an individual user tool.
Yeah, and if it is a user tool, it's probably not going to be at a scale that matters.
Okay, so it seems like the answer is don't worry about that, right? Are there any other sort of comments, questions, or suggestions about CAP33 orbit steps?
Yep. Actually, one more note. As I mentioned earlier, I'm a bit worried about the locked funds clawback logic. Without it, this proposal seems incomplete, and the sponsoring entity has no means to recover its funds from the dormant sponsored accounts. We agreed to think on this later. So just for the record, I think it's important to articulate this. To articulate the timeline for this feature. Like this year, the desired feature list is fully packed, but next year we'll definitely introduce some way to deal with such situations, because companies that are willing to sponsor reserves for their client accounts must have confidence that they will be able to claim their locked funds in the future. I think it's an important part.
If you have some ideas about how to do this, I mean, like I would definitely welcome a proposal about how to do this. I definitely think that'd be valuable. I haven't really spent any time thinking about how to do this, other than the fact that it's like probably possible with the current design, albeit like probably not that easy. But yeah, if you have an idea, like definitely like submit a proposal. I'll definitely look at it. So I've spent like a ton of time thinking about this now, so I have lots of context on it.
Sure, we'll do this.
Okay, great. I mean, I feel like even though it seems like there's still a little bit to be resolved on Cap 23, Cap 33 is feeling like it's in a pretty good spot. And obviously these are things that we're intending to include in Protocol 14. And already the Horizon team and people that work on SDKs have started to think about what that means. And so I know Eric put together a working group to sort of go through some of the issues, figure out some decisions, and I think he's going to give us a summary of where they're at.
Yeah, I don't have a huge amount to sort of say in person, except to say that we had a lot of discussions. We went through and tried to think about use cases. And then we tried to think about how this stuff would actually work. And we came up with problems in the caps, and we went back and modified the cap. And then we came back again. We went around this loop a few times. So it was really, really useful. I've linked to a discussion doc in our agenda that you can look at to see kind of the gory details. An FAQ is coming out of this, which will be helpful for the ecosystem, I think. And the outcome now, I think, is that we have a spec that's pretty solid. So there are two issues in the Go mono repo, 2787 and 2788, that you can have a look at, that really describe the endpoints that we expect in Horizon and the work that we expect to do in the SDKs. And anything that's remaining that's unclear, I'm kind of satisfied is implementation level problems. How do you put things in what tables, that kind of stuff. So I'm pretty happy with it. The only other thing to mention, I'm just going to mention this briefly. I know Lee didn't really want me to, but there is a naming question in the Cap 33, whether we should rename these operations to something more clear, because one of the things that we ran into in this discussion was that we kept getting confused about what certain operations actually meant. And if we're confused, then everybody else is going to be confused. This is relevant to Horizon because we have to name our SDK functions and our endpoints according to what we decide the actual operations are. So there's a mailing list discussion about that. I'm hoping we'll get an agreement on it. I like the new names. I think we should keep them. But we'll need that in order to actually make the final implementation.
What are the new names and what are the old names?
Lee, do you want to talk about this?
Sure. Yeah, I don't have an issue talking about it. The sponsoring future reserves, I think. So we're sponsoring future reserves, confirm and clear sponsorship, and then update sponsorship. They were the original. And the new proposed names are begin sponsoring future reserves, end sponsoring future reserves. So it's really clear that that's a sandwich. And then the third operation renamed from update sponsorship to revoke sponsorship, because that third operation is signed by the person letting go of a sponsorship or letting go of paying the reserve for the account.
Yeah, I agree with all three of those, particularly the third one.
Yeah, that seems nice and clear. I mean, there's a lot of letters in some of those names, but they're also super clear.
We're gonna hit our 80 character limits in the on the lines of the XDR file after like one word.
So as far as you can see right now, from your point of view, Eric, no surprise database migrations.
No, it looks good to me. Yeah, I'm pretty happy with it.
Cool. Any other questions about sort of prep for Protocol 14 downstream, or about what Eric just sort of summarized?
I guess it's worth mentioning as well that I expect us to begin implementation of this in our next sprint, which will be in about a week and a half's time, unless something comes up to dissuade us or ask us to spend more time.
So those like pending decisions about Cap 23, do they have an impact on that timetable that's significant?
I don't think so. I think those
Just
are internal.
That's
cool.
super exciting, Eric. Hopefully I'll have something decently functional for you guys to test off of by then.
Yeah, when you can get me a core build, we'll get going.
It looks like there's one final small issue, which is started as issue 622, change close time semantics. I think it's now cap 34, or which is in the draft. Nico, you want to just summarize that real quick?
Yeah, like the cap is not yet in a good draft form. It's pretty rough. So I'll just focus on describing at a high level what this cap is about, which is actually, yeah, we had like a bunch of ideas going around in the issue itself. And this is really a annoyance in the current protocol. So this is not impacting SDKs or Horizon. It's more impacting. If the only people that are getting impacted are going to be impacted in a positive way, which are people that write transactions that, in the context of smart contracts, that have expiration times, and it's basically closing an edge case that nobody's probably aware of when they write those smart contracts, that today a transaction can fail during consensus time, basically consuming the sequence number, even though the time bound that was specified would make this transaction invalid. So basically, like the typical scenario is when you do smart contracts is you have mutually exclusive transactions on a time bound. One is, for example, only valid before a certain date, and the other is valid only after. And then those are like your two branches of execution, basically. And here what we have is, it's possible that let's say the first one, which is only valid before a certain time, would be accepted for consensus. And then only you would find it to fail during consensus because the close time that was picked during consensus is actually incompatible with that one transaction. This is very annoying because now if you have this one transaction failing in your branch, that means, like, normally people, what they do is they change their transactions with hashes, right? And now that particular path basically becomes possible because you consume the sequence number, but you didn't actually execute that one transaction. So that smart contract is kind of in a broken state. So it's a very edge. It's a really an edge case, and because it's an edge case, yeah, we want to get rid of it. Anyway, so the fix for it that that we came up with David was to during consensus, basically this pick as close time the one that is associated with the transaction set. So normally when nodes nominate a value in general, so the value is made of transaction set, close time, and upgrades. Right now, what we do is that when we, at the end of nomination, we combine all those values into some more interesting value that is a transaction set that is one of the transaction sets that made it to the end of nomination, and then a close time that is the biggest close time. So instead, what we're going to do is we're going to preserve the affinity of transaction set to close time. And by preserving the affinity, what we can do is actually change the validity criteria for a transaction set. I mean, for the pair transaction set close time to only allow transactions that are going to not be expired with that given transaction set. So basically, it's pushing the burden to the nominated value in terms of like the actual change is that, and then we'll basically not even include those transactions that would expire between two ledgers in the transaction set. So that's the gist of the change. So it's not a big change, but it potentially will make it can be life-changing for those people that may hit that bug.
Do we have actual use cases that are running into this?
I mean, we see, so the thing that we see those transactions fail today on the ledger. So people are running into this.
It has definitely happened before in production.
It happens. We don't know in the context of smart
people
contracts.
lost money because of this.
No, well, that we don't know. Yeah, that we don't know, and we don't even know for future like contracts that didn't even that didn't happen yet, right? Like that's the problem with those things, that they are pre-signed. We don't know yet what the impact is.
Here's my concern. So I agree this is a problem, and I think there are a number of ways that we could fix this problem, including this, which seems like a plausible way. Another way would be the kind of signed operations proposal that I made. Just on the mailing list. But the problem is that all of these things, they eliminate some edge cases and introduce other edge cases. And so I'm just a little apprehensive about doing it sort of in the abstract, because so for example, this new proposal would definitely would like avoid an edge case where like, you've got a payment channel and you submitted something and it like expired, and like you would have submitted something else otherwise, and now your sequence numbers are messed up. On the other hand, under the current proposal, there's a danger that if someone is doing like atomic cross-chain swaps, that it would work today. And with this proposal, if there's a network outage, you could actually lose money, right? Because
no, like this is fixing an edge case where you're guaranteed that the transaction fails. It will not exclude transactions that would succeed.
So okay, so the fact, so either I'm misunderstanding it or you're misunderstanding, but either way, it's an indication that this is an edge case, which is, so imagine that what we're trying to do is we're going to swap lumens for Bitcoin, right? And so what I need to do is I'm going to claim my lumens, and in order to claim my lumens, I'm going to use a #X signature, and by disclosing that, someone's going to be able to like claim their Bitcoin, right? And I have to do my thing by a certain deadline, and then the Bitcoin person has an extra hour to like take the pre-image that they found in the Stellar transaction and use that to claim the Bitcoin on the Bitcoin network, right? So under this new proposal, if the Stellar network goes down for an hour, it's possible for an operation to actually execute, even though it was supposed to execute at most 1 hour ago, right? And so, again, so this will require DOSing the network and getting a little bit lucky with the time of an outage. But if you're trading enough Bitcoin for lumens, that's something you would be concerned with. So again, I'm not saying it's a bad idea, but I'm saying it causes potentially other problems that people now have to worry about.
I'm not actually understanding what you're describing, because if I don't,
this problem already exists, David.
Yeah.
What?
This problem already exists. I actually messaged Justin about this, like a very similar problem this morning, like 2 hours ago. Like right now, imagine this like super terrible thing happened. Imagine that you submitted a bunch of transactions, like I submitted some transactions, Nicola, David, Lee, Orbit, Justin too. Like we all submit a bunch of transactions, and like Eric also submits a transaction, but Eric's name starts with E, and that means that he's malicious in conventional, crypto stories. And Eric knows of some 0 day that allows you to crash the network at externalized time. And so what happens is like Eric's transaction gets into the ledger, all of our transactions get into the ledger. And now the network is dead. Like it crashes during, ledger close. And nobody externalizes as a consequence. Everybody crashes. Now, like when you restart the network, it's going to crash again because you're committed to this transaction set. So the only thing you can do is update the software, blah, blah, blah. Let's say this takes like 36 to 48 hours probably to get everybody back up and running. Right. It would be like, I think, a reasonable guess. Maybe even a conservative guess. But like, you should not consider any transaction expired on the Stellar network until you've seen a close time past that time. Once you've seen a close time past that time, you can say that that transaction is expired. But until then, you cannot. Because no matter what model we use, like it's possible that the difference between like the clock close time, when the like ledger actually externalizes, and when the like I don't know what to call it, the Stellar header close time could be like arbitrarily far apart. So this problem exists today. Like if you get into this situation, like that transaction might execute until that ledger close time stamps.
I think this is a different problem. So this is also a problem. But the problem I was concerned with is that a transaction with an older timestamp might not get disclosed until long after that timestamp, right? And if the contents of that transaction unlock something on a different blockchain, then that's a problem.
Can you give some more background on this? I'm not sure I understand how that would happen. Like,
so okay, so basically we propose a block with a particular time, right? And that time was an hour ago because, and in my case, you don't need a software fault. It could be like some botnet attacks Stellar or something, right? So it takes us an hour to like recover from this thing. And now we're going to execute transactions that were like an hour old because like it's still the biggest block that's been nominated, right? Even though at this point, like everybody should be nominating everything, but it could be that the block an hour ago was like the biggest block, or nobody's heard of newer transactions, right? So even though other people should be nominating like higher timestamps, we'll execute with like an old timestamp, and so people might learn about a transaction with the timestamp of 11 a.m. at like 12 p.m.
but like, shouldn't you only vote for a transaction set or a Stellar value that has a timestamp that's close to your clock time? So like, if everybody thinks that that transaction is super old, nobody should vote for it because it doesn't have a good close time.
No, you should vote for anything anyone else is, any one of your leaders is voting for.
But only if it's valid.
And then you should take, and currently, yeah, only if it's valid, the transaction set.
Should we consider a transaction with a super old close time valid? Do we even do that today?
A block with a value with a super old close time.
That's what I meant, a value. I don't think that even happens today. I think that if it's older than like 60 seconds, it's dead. Nicola would know the best, so I'm going to let Nicola take over.
No, like it can be any clock in between the last ledger and the current time, more or less. That can be introduced as a potential, but we pick the highest anyway. So if you have multiple,
right, but this proposal is going to change that. So I think that my point is that
no, we don't change that. We don't change the fact that like the likely close time to win in that situation is going to be in approximately current time.
Oh,
okay. Wait. That's confusing. Actually, hold on. That's not what I inferred from the proposal.
No, like
that means that you would choose a newer close time with a worse transaction set.
No. But like it's when you have nodes nominating, a pair transaction set close time. The close time that they nominate, they introduce on the network, is their local clock time, right? So that's so if you work there for like an hour, during the last ledger, that new ledger will be an hour later, basically, like compared to that. So it's actually snapping to the current time. It doesn't.
But a malicious node could say that it nominated something with an old time, right? Like, is there anything stopping them from doing that?
There's a race, right? So like the DOS can happen at any node can be DOS, right? So any node can introduce a close time. So in this particular situation, the change of picking, I guess that's where the change is. You may end up with picking the transaction set close time pair from one node that actually decided that it was not going to nominate something that was close to the current time, like instead something in the past, but close to but bigger than the last close time.
I just want to say, by the way, that we're fast approaching the end of the hour. So I don't necessarily want to cut this discussion off, but at some point I think we'll stop the live stream and figure out the best way to have this discussion move forward. Does that make sense to people?
I mean, basically what I would like to do is I would like to either have you know, a little bit more data about like sort of smart contracts and stuff, just to make sure that we're not sort of solving one problem and creating another. And second of all, maybe a little bit broader discussion, because the point is like these sequence numbers are actually like annoying in more ways than one. And so it could be that if we solve the sequence number problem, then this issue goes away and we haven't had to also create this potential annoyance for like atomic cross-chain swaps.
So there is already a way to avoid this sequence number problem. I actually described it in issue 622 like 3 or 4 hours ago. But the basic concept here is like, instead of letting your transactions have sequential sequence numbers, they have gapped sequence numbers where like you could choose a gap of 1, for example, right. And then the transaction just needs to have a bump seek. And so if it fails, you know that
Yes.
that it didn't happen.
And that would solve so many other, it would like solve a whole bunch of other problems too. So it's like, I'd way rather just like kind of address that problem rather than just do this one thing that's targeting this one very specific problem, which we don't even know is exactly the problem that people are having in practice.
Well, we know it. We are running into this for regular transactions.
No. But all we know is that some transactions are getting submitted that have a bad close time, right? But we don't know that that's like messing up people's smart contracts, and you know, those people might not care that they're losing, you know, 100 micro or 10 microlumen fee or whatever. Like it just might not be a big deal to them.
Wait,
So you want us to put a face to those to those transactions?
Yeah,
cannot.
because there'd be so much upside to actually allowing the gapped sequence numbers, like because that would solve all these other problems too. So like if
but that's a separate issue. Like here, what we're talking about is that there might be smart contracts out there that are broken because the way things are actually specified is wrong.
Right, and what I'm telling you is that if you allow gap sequence numbers, it will solve so many other.
I understand
with
what I'm
smart
saying,
contracts,
yes.
including this problem, right?
No, you would have to change.
This only would affect
contract.
new ones.
Yeah, new ones would be fixed, but you wouldn't fix old.
And you could already do this using
any
bump
smart
seek.
contracts in use. We don't know that there's any smart contracts in use. You can't
Exactly.
say that.
We don't
We
know.
also don't know that there aren't, right?
Sure, but like, let's let people complain about a problem before we.
The thing, well, but the thing is that
this might be
wait.
create another problem that might be.
The smart contract we're describing here is the very, I think in most examples of smart contracts, the branch on time. Like you want something valid, a branch before some time and a different branch on a different. That's like the smart contract 101.
I would argue it isn't. I would argue smart contract 101 is the cross-chain swap, right?
Well, I think, I think like you bring up a super good point here, which is like anything that we're proposing as a solution here, like we better test it to make sure that it should be Pareto better, right? Like if I'm not happy with a solution that fixes this problem but makes cross-chain swaps worse, so like probably.
But it doesn't.
I don't know if it doesn't. I don't think it does. I don't think it does.
Look,
I
I think right now what we should do
is should be part of the cap.
That was the thing, right? We're going to have a conversation on the dev mailing list for this one. And David, if you can show us how this breaks cross chain swap, happy to
But
listen to that.
I'd rather fix things than break things. So John, if you have another idea for how to do gap sequence numbers besides my signed, I had that one proposal for the signed operations, but basically something simpler. Like I think I'd rather just argue if we have something that like I can argue fixes this problem but also fixes other problems, I'd rather spend my efforts arguing in favor of something rather than against
but we'll still have the same problem. That's the problem with any other solution. We'll keep the close time broken in terms of the spec.
Well, no. If we have gap sequence numbers, then there's no issue because I can basically submit the transaction.
You will have, so right now in the spec, we say if you have time bounds, the bad time bounds, the transaction is invalid. That's what the spec says. And we're actually not doing that.
That feels like a good place to end. I think we should end right there. Continue this on 622. Thanks everybody for watching. That's the end of this week's Open Protocol meeting. See you in 2 weeks.